Today I'll be talking about a robotics project I made. I'll be talking about a few qualities needed to make this project fully from scratch and the components included in it. And finally, without wasting any time, the demonstration after. Firstly, let's dive into the skills needed for this project. You need to have a deep understanding of gyroscopic precession and CMGs, which is a short form for control moment gyroscopes. You also need expertise in electronics and tools management, including using the glue gun and the soldering iron safely. You also need experience in building robots from scratch, coding in integrated development environments, and picking the right microcontroller for the job. This also includes designing organized circuits to further help you. On top of that, a little bit of knowledge is required for the IoT part. And in my opinion, the hardest skill is the patience required for these robotics projects, which lead me to the next skill, analyzing and debugging skills. These skills are essential to find problems and fix it. I just want to mention that this is my third redesign prototype in 6 continuous working days while rewiring the circuit 4 whole times. I'm learning a lot from my projects, and I'm sure that this robot still hasn't reached its full potential yet. I'm still learning through the process and have a great adventure ahead of me. Now, without further ado, let's get to what components are used and how this project actually works. So now I'm gonna show you all the components included in this robot. Let's first start from the right side. So first, over here we have an ESP-32 board, we have a potentiometer, we have a IR sensor which is measuring analog signals, so there might be some with only digital signals. We have a servo motor here, we have a DC motor here, and then we have a heavy wheel. What I mean by that is that there are bolts inside, as you can see inside, to increase the mass. So that will lead to increase in angular momentum. Now we'll go over here. So we have a battery, we have a connector to connect wires together and acts like a switch. And then finally we got a pivot area, so when this motor moves, the servo motor moves, it will rotate this also. So this is what will create the motion which will make the robot move like this. Finally, to power the DC motor to make it go fast and powering the servo motor, we have a USB type A connector. We just connect this and it will power this, which will make it go fast and make it more efficient. So that is all the components used. There are some wires also, some glue used, some wooden sticks, and other materials like that. I just want to show you what it's like. What this robot's gonna do, if I push it like this, it will instantly go back with no oscillations. But now when I do it without this robot turned on, as you can see, it just falls over. So over here I've already started the robot, so it's all powered up. You can change the set point by this potentiometer easily, so I don't have to code it and wait for it to upload, because it takes about 1 minute-ish to upload. So I can just change it. This is already calibrated, which is good. And I've opened the Firebase real-time data, so it's sending Wi-Fi signals to here, and data is getting received. It will become yellow color when it receives data. Now I choose Firebase because it's relatively faster than other clouds. So let's now start with the actual demonstration. So remember the pushes which I did before by pushing it here and there. So the oscillations there was, it didn't even oscillate, it just fell down. So now let's try that same thing, same power, and here we go. as you can see, it didn't oscillate too much. Let me try that again. This side. So as you can see, this is moving to adjust, and this control moment gyroscope is actually used in spaceships also, because there is nothing to push on in space. So that's why this is another use for control moment gyroscopes. That's just a fun fact. So it's pretty simple and easy and doesn't take many resources to build. And as you can see, it's updating the sensor values it's receiving. So as you can see, if I bring this closer down, so the sensor gets closer, the values are decreasing. When I bring it back up, it's increasing back. So that's basically how it works. It's very simple. If I just try it again, there you go. There you go. Thank you for watching and hope you had a great time.